Xiong-Yao, and I'm a team member of the ECCDH3DES team, with other team members including Nico, Lucas, and Manish. So I'll be talking about our algorithm. Our code is divided into three main parts: our ECC key generation algorithm, Diffie-Hellman key exchange, and triple DES encryption and decryption. So right now I have SSH into two FPGA boards, with the left pane signifying person A, the right pane being person B. And we have all the code loaded and ready to go. So the very first thing I'm going to do is generate a private key for person A. So we're going to name it pri.a.txt. And we're going to be doing the same thing for person B. b.txt. And just to let you guys see that the keys are different, I'll print them out for you. And for person A, you see that the private keys are different. So once we have the private key, we're going to be generating a public key. And to do that, you have to run the generate and then say store that public local, using the local folder, meaning it's the public key generated from person A.txt. So what it does, it will go through, call the ECC algorithm, which will essentially do a point multiplication on the private key generated and a NIST approved point. And here I'll show you guys the public key as generated. Same thing goes for B. I have to make a public key for B also, calling the private key in B, store it in the local, name it as pub.b.txt. And here I'll show you public key for person B. As you can see, the generated public keys are different. So this is where Diffie-Hellman key exchange algorithm comes in. I'm going to send public key from person B over to person A, and I have the command typed in, so let me find it first. So I'll send it over to external, meaning it's a public key transferred from another person. And we'll do the same thing for person A. Should be SCP. And we're just using SCP as a example of how one can transfer keys or data from one person to another. And you're by no means limited by your method of transferring. So now person B has the public key of person A. And I will show you the key that I got from person B. Oops, and I'll show you the key that I got from person A. Using these two keys, we're going to have to encrypt the file with them. So in this demo, person A will be doing the encryption and person B will be doing the decryption. So to do that, we'll run the command make test_encrypt. But before we do that, I'll show you what we're encrypting. So we'll be encrypting a poem by Edgar Allan Poe, The Raven. And we'll go back to running the command test_encrypt. So what it does is it will use the public key of person B and the private key of person A. It will create a session key from them using ECC point multiplication, and using the generated key, triple DES will be able to use the generated key to encrypt the file, and I will show you the encrypted file. And yes, you can see everything's encrypted. Now I'm going to send the encrypted text to person B. And I also have the command typed in. And person B will get the encrypted text, and just to double check, so you can see the file is transferred down. Person B will then want to decrypt the file, and we can show you that the decrypted folder is empty right now, that there's nothing in them. So now we're going to run the decryption algorithm. And we do the same thing. Using the private key of person B and public key of person A, it will generate a session key, and passing down the key to ECCDH3DES to use it for decryption. Now that the algorithm is done, I'm going to show you the decrypted file. And as you can see, the Raven is correctly decrypted. And this is just a quick demo of how our code can be used for key exchange, key generation, encryption, and decryption. And you're by no means limited by the file type that you want to send or decrypt. And we're just using a text file to prove as a simple demo. Thank you very much, and I hope you guys enjoyed the video.